Yes.
Hello, Jaime. You're usually
Hello.
here. Hello. I would
Yes.
like to record this session, please.
Yes, it's recording now.
Okay, thank you so much. Appreciate that. Excellent. So welcome, everybody. Just that is the order for the session. And without further ado, I will stop sharing. And I will pass over to Thomas. You have 15 minutes. Off you go.
All right. Thank you very much. And hello, Working Group 2. I will try to share my screen. I wonder when I will become comfortable with Teams. It hasn't happened yet.
I know we use so many different tools.
Yeah.
So we see your screen not in presentation view yet. And now it is. There it is.
Good.
It looks
All right.
fine.
So I did reach out here because I understood that you in your MASS group here was beginning to look a bit on infrastructure and platforms to support MASS. So I thought I would kick in with a little input there. So that's why I asked for a small presentation here. So first of all, my first point is I think in general, and I think we're all agreeing on that the different technical eNavigation services that we are producing as part of the eNavigation initiative, most of those are also going to be used by MASS. I think we're making machine-to-machine services, and most of those will be relevant and used for MASS. Maybe in the process of developing the different technical services, we need to also assess the MASS case to see if we need to flip a bit or something to make sure that this is also fit for the MASS case. And then, of course, we probably will define a new overall maritime services with new associated technical services specifically dedicated to support MASS that will extend the total portfolio of technical services that we are developing. So I think all the building blocks that we are working with now, and all the guidelines that we have for developing technical eNavigation services, like the guideline for developing technical eNavigation services itself, and the MRN and S100, and the guideline for web-based services, and all these things, I believe that they are going to be used and be relevant and be fit for purpose of MASS as well. But then, as with the technical services in general, there is a further need for some digital infrastructure and platforms. So that is why Ayala recently made this new guideline on evaluation of platforms for the provision of maritime services, maybe you should say technical services there, in the context of eNavigation. So that's a new guideline that focuses on the need of platforms to support the technical eNavigation services, and that guideline is, well, definitely relevant for MASS as well. It will also need the same type of platforms that is identified and discussed in this guideline. The guideline highlights several different things, but some of the core elements here is the need for authentication and authorization, and the need for service management and service discoverability. And of course, this is where I come in with the MCP, because this is what the MCP was built for, as you probably have heard before. And we have the identity registry as part of the MCP that can support authentication of different entities, stakeholders, MASS vessels, anything that they can authenticate themselves. So we're sure that we are exchanging information with who we think we're exchanging information with. So this is really the core requirement for such a platform for eNavigation, that we are able to do that. and which is what the MCP is built to do. And another very basic thing is the service registry. Imagine an autonomous vessel coming in, closing in on a port somewhere, and it wants to know information about the port, the location of the right berth, and maybe some specific route it needs to take, and it needs to find the services coming from that port, but it may be going to a new port all the time, so it doesn't know where these services are. So it requests, it queries the service registry to find the services, the local services it needs in order to do the operation that it needs to undertake. So that is why we have the service registry as part of the MCP. It is developed to facilitate and support the IALA guideline for technical services, D1128, and important elements in the search is the geographical search, so that you can request for specific services in a specific geographical area. And I think this is, yeah, again, super relevant and important for MASS. Then the guideline, the IALA guideline, it talks about platforms, several platforms. Do we want several platforms? Well, this either is several platforms that needs to be harmonized and interoperable, or it is one platform that is decentralized. And from my perspective, this is the same. This is, okay, we have several platforms, but they are acting the same, or we have one that is decentralized, same. So either we have, hi Michael. So either we have the several platforms that need to be harmonized, or we have one that is decentralized. And either way, we need to have somebody that that is basically what it says on this slide here. We have either the harmonized single platform or one that is decentralized. But someone needs to be able to ensure this harmonization, must be able to develop the standards and the procedures in order to have such harmonized platforms or a decentralized platform. So we need some kind of government governing body for that. And of course, that is the role of the MCP consortium when it comes to the MCP. And the MCP is indeed a decentralized solution where we have different MCP service providers. Most of you know of the Navalink that is running commercial MCP, and there's the governmental MCP in Korea, and we're having another one that is being set up in Finland and possibly in Russia and other areas as well. So there will be different MCP service providers, but they will all function in the way. They will be interoperable, ensuring that you can use any MCP instance that you wish. And in order to govern this, we have the MCP consortium that has been set up in the same way as we have the World Wide Web consortium that is governing many of the standards on the internet, and it is being set up with a board that is run by non-governmental, non-profit organizations, and anybody else can be regular members and take part in the General Assembly, that is the highest governing organ of the consortium. So this is very quickly an overview of the MCP, and I think this is definitely something that is needed to support MASS. and we have it now. We have just released the the first version of the specifications for the identity registry. So that is actually in version 1 now, and the service registry and the messaging service, other components of the MCP are coming along, and are also being developed. All right, that was all for me. Very quick, so I think I've comfortably been within the time limitations.
Thank you very much. You have been wonderfully within time limitations. I appreciate that very much. And we do have time for some questions, if there are any questions on the MCP and the role of MCP in math. Christopher, just to let you know, your mic is not muted, and so just in case you think you are muted, and you aren't. So Christopher Senark, that's much better. Thank you. Appreciate that. Are there any questions? I'm also looking in the chat box to see if there's any questions popping up in the chat box. I don't see any questions in the chat box, which is quite amazing. I thought there would be some questions on this. Thank you very much for the presentation and the role of MCP. Could I ask you to go back to the slide again about the thoughts on the different one service or two services, because we did went through there very quickly on that one, and maybe we've got just a second. That's, I think, really where we're coming to some of the crux here about how we're going to be seeing it all work within this concept. So from my understanding, the MCP provides this sort of this oversight to say that a service is agreed or not agreed. It doesn't touch on the technology. It's another, the technology itself for the service provision would be a label below that. Is that correct?
Well, the services can be registered in the service registry, but then there will be also a decentralized trust system on top of that, so that you can have different organizations endorsing different technical services. So, for instance, IALA would be able to go in and endorse technical services belonging to their domain, for instance, VTS services, so that you will be able to see in the service registry whether this is a standard that has been approved by IALA or IHO or IMO or which other international body that would be relevant for a specific service. And you can also see the identity of the service provider that they are who they claim to be. So you have both the levels, both the trust of the service provider and service consumer, if that is needed, and then you can also see if this specific service specification has been endorsed by the right international organization.
Okay, thank you. Yeah, thank you for that. And we do have one hand up, Michael Bergmann.
Thank you very much. So first of all, I think it's very important that we realize that the MCP is capable of handling international larger type of data exchange and is not specified to a certain region or to a certain technology. I think that is extremely important when we are looking at mass for ocean-going vessels, for example. So from that point of view, I fully support that, what Thomas was saying. The other thing, a bit to the question you just were raising, Gillian, is if there is a certain instance provider, and this instance provider has registered a service. Let me say you have a VTS registered in the service in the Finnish MCP instance. If I, as a user, have registered in Navilinx MCP instance, I must be able to also discover the service of the VTS, which is registered in the Finnish MCP instance. From that point of view, the MCC, the Maritime Connectivity Consortium, has developed those standards and interoperability that you are not need to register in all the MCP instance to receive all the services, but you register in one MCP instance And from a service provider point of view, your services are available to anybody who is registered to any kind of MCP instance. And if you're an MCP instance user, you can discover any services regardless whether they are registered within your MCP instance or not. And that has some influence on the technology, because the technology needs to be in a position to actually interact with each other. And Thomas has explained to that. I think that is something which is important, both for the service providers, for example, for the VTS, where we talk here about that, but also for the registered users. Thanks.
Thank you very much. And I'm just, again, going back to this, the role that we've been looking at with regards to this in our working group here at ENAV Working Group 2 is really at that digital technology, data exchange, Internet of Things concept. So thank you for that, and for the clarification on the different registers and the different instances and how they're registered and working together. Thank you. And I see any more hands going? No, I don't. Thank you very, very much for your presentation, Thomas. And I will now then move to Todd, your presentation on the work that you've been doing with non-linear decision support and automation in VTS. Over to you, Todd.
Thank you, Jillian. Can you hear me?
Yes, I can hear you, and I can see your slide.
Oh, awesome. Okay, so we're ready to go then. Yeah, this is a great chance to talk about some of the things that we've been doing in the area of non-linear decision support, automation, eNavigation. And so as you probably know, the company I work for is in the business of maritime domain awareness solutions. And so I see all of this through the lens of VTS. And these topics are part of what we call the next generation VTS. And what you see here are some of the highlights of the next generation system. So behavioral analysis, which is where nonlinear decision support sort of falls under something that we call BEAN. That is rather central, as is eNavigation and autonomous ships. Another aspect that's super important is open architecture. That is, one of the things we consider to be foundational, because we're hearing more and more that end users are really not interested in vendor lock. If a particular authority selects one VTS technology provider, then they are pretty much, at this point in time, they are tied to that vendor for the life cycle of the system. And what we are hearing increasingly from folks is that they are not interested in that. They want something that's a little bit more plug and play. And so the next generation system that we are offering is more plug and play. And that's through the use of APIs, open standards, and the traditional sorts of open architecture technologies. We are involved in several innovation and development projects that support the development of the next generation VTS, and all of these projects have something to do with eNavigation and autonomy. This is most of them, I think. And one of these projects that you see here is the MPA Living Lab, also known as the MPA Maritime Innovation Lab. I'll be talking some more about that program in particular today. Autonomous ships, an important aspect of the next generation of VTS, and I'm putting these projects up that Kongsberg is involved in, just to let you know that where I'm coming from is we don't have a theoretical understanding of autonomy. We are actually involved in the development and delivery of autonomous ships, autonomous systems, remote operation centers, this sort of thing. And so the work that we are doing and the things that I will be talking about are very much grounded in reality. So today, and what I'd like to talk about is the Maritime Innovation Lab, specifically the next generation VTMS lab, as part of the Singapore MPA Maritime Innovation Lab. This is a very large project that we were involved in. It's where we did a lot of our work in nonlinear decision support. As you can see here, it has a number of different blocks. A lot of them are overlapping. There are a few of them that were quite successful, and some others that were not as successful. And a number of smaller services, as you can see down here, were developed. I would like to focus today on these areas here. This is where we struggled the most and learned the most as well. So the maritime services, Maritime Service 1, 2, 3, and 5. These services, as you know, are probably, well, the first 3 services are probably going to be reduced to something like this, perhaps VTS Service, Maritime Service 1. Perhaps that's what it'll be called. We also delivered a Maritime Service number 5. And one of the challenges that we encountered was how to define and to sort of operationalize information, NAS and TOS services in the context of eNavigation. So regardless of how these services will be defined within the VTS world, it is actually rather important from a technology provider's perspective to know specifically what data is going to be shared ship to shore and vice versa in these services. And that was really not specified well when the project began. Now, by the time we had finished and demonstrated, there was an IMO MSc document on providing an initial description of the maritime services, but that document did not exist when we started the project. And we did demonstrate it. For those of you, and Jillian, I know you were part of the workshop, and several other folks here perhaps were as well, but this was demonstrated during the IALA eNavigation workshop in April of 2019. And what exactly did we demonstrate? Well, in negotiations with MPA, we worked out that a Maritime Service 1, 2, and 3 would provide this sort of service, that a vessel would be able to send its pre-arrival notification and route to the VTS. The VTS would be able to send a welcome message to the vessel. Vessel could be able, then would be able to subscribe to certain services. In this case, it was navigational warnings and maritime safety information. The VTS would then be able to send information about conflicting vessels in the area. And this was done through a decision support service. And so if there was a conflict that was detected, a graphical representation of the conflict would be sent to the vessel and would be displayed on the ectus of the ship. And the ship would then be able to make a decision about what to do based on that information. And so we demonstrated that during the workshop, and as an aside, it was sent over VDS. So we learned that VDS was a good carrier for that sort of information. We also demonstrated how a Maritime Service number 5, maritime safety information, what that might look like in the context of eNavigation. And for this, we sent a filled and colored polygon representing a dredging area to the ship, and it was displayed on the ECDIS there as well. So these are some examples of what we did with eNavigation in the next generation VTMS lab. And this up here is basically what constituted a VTS service in the context of eNavigation. So what did we learn? Well, we learned that at that time, the content of the maritime services were not really all that well defined. They are better defined now, but at that time, they were not well defined. And this was a potentially, say, dangerous situation, because if the content of the service is not defined, then it can lead to a non-harmonized delivery of the service. Vessels won't know what they're going to be getting when they get a VTS, when they subscribe to a VTS service, for example. We learned that there's this technology called Web Map Services, WMS. It's an international standard. Works great for delivering graphical content to an ECDIS, and most ECDISs support WMS. So that was an interesting thing to learn. And we also learned that black box or anonymous decision support solutions not widely trusted by VTS operators. And so when it comes to these sorts of nonlinear decision support services, first of all, they are difficult to develop because they require a great amount of data. And so there needs to be a commitment on the side of the authority to provide historical traffic data to develop these services. And that is a challenge in most areas. Another roadblock is trust. And trust is a human intention. It's an intention basically to allow yourself to be vulnerable, and that you'll have some sort of positive expectation about how things are going to work out. So you can think about trust in relationships, okay, and also then trust in the technology. So you have to have a positive expectation, and you have to be sort of vulnerable to how the technology is going to go. And then there's the issue of trustworthiness of the technology, and that is, and trustworthiness is a property of technology, and it's something that is closely linked to reliability. And trust often doesn't come unless you have a great deal of experience or history with the technology. And so what we found in delivering this technology to the VTS was that it's really important that operators understand how the autonomy works, and how the black box works, the nonlinear decision support works. Transparency is very important. So communication in the process of providing the information is important. So things like it being dynamic. That the technology sort of shows that it's working on a problem. This is rather important. And also appearances are important too. Does it sort of look trustworthy? Does it look advanced and modern? This is all rather important for humans to be able to trust it. And also time. Time is a rather important part of developing trust in autonomy as well. And so what you see on the right side of the screen here is an initial attempt to provide some information to operators to get them to trust hotspot detection. So, because what you're seeing here is hotspot detection, and you can judge whether or not this was, how good an iteration this was, but it was the first iteration. And finally, I just thought that I would throw this up here because this is where Kongsberg is at in terms of our development of digitalized e-navigation services. Most of these are e-navigation services, and what sort of equipment it shows up on, or the user interfaces. And when it comes to autonomous ships, this is what we are looking at as the maritime services or the e-navigation technologies that we will use in the autonomous ships that we are delivering, and the innovation projects that we are working on, so that all of the remote operation centers will be able to support these sorts of technologies. That is it for me. And so with that, I will turn off my microphone and hand things over to you, Jillian.
Thank you. I was going to say, don't turn off your microphone just yet in case there's some questions, because you've done very well. Thank you very much. Everyone's sticking right to time. It must have been all those emails I sent out with that detailed timing on it. Thank you very much. Very interesting. And just following on from that presentation on the MCP and MASS, and then the data exchange that you're doing there within this concept, did you use the MCP for that exchange concept that you were doing?
Oops. Okay. So in the, you don't need my camera for this.
Yeah.
Yeah. So in the lab, what we did was initially we put up a dummy MCP. So it was a sort of a scaled down version of the MCP that we built up in the lab itself. And for the latest demonstration, actually the final demonstration we have yet to give, and that will use NavLink. So
Okay.
so yes, and I should also note that NavLink, the commercial instance of the MCP that we have, that will also be used in the autonomous projects like AutoShip, which involves a couple of different autonomous vessels, one in the Flemish inland waterways and another short sea shipping one. It is also, though the Yara Birkeland and these OSCO barges that will be operated in Norway, they will also use the maritime services provided via NavLink.
Okay, thank you for that. Are there any questions? I have one more, but I'll wait and see if there's any other questions from the group first. Well, while we're waiting, could I ask you to put the presentation back up again? And I'd like to go back to the two slides where you went from the view, sort of like the current view, and then you flipped it around and you went to the MASS view. I'd just like to see that one more time because it went through very quickly and I was trying to capture all of the data on the slide there as you moved. Do you know the two slides I mean? You've got the VTS center and the ship view and the VTS view, and then you switch it around and it moves it over.
This one, right?
Yes, that one, and then that one, and then, okay, so this is where we're at now. And I'm just trying to think all of the things that you've got there, because I did, there's the NavLink, there it is, I knew I saw it there. And you use VDES to transfer all this data, so from a data technical point of view, the data wasn't too big for that?
Well, no, we should also say that not a lot of, but some of this data will not use VDS, but some of it will, and this is by no means the end either. We see that within the context of maritime autonomous surface ships, that technologies like virtual ATONs have untapped potential there, and smart buoys. These things are we have not even begun to fully exploit them. So I think that that's something that is going to be coming probably, if we're talking a year from now, we'll have a lot more to say about that. But the remote operation centers, because they will have the same domain awareness solution as the VTS centers in Norway, then they are going to be capable of handling virtual ATONs and also able to receive meteorological and hydrological data through ASM messages, which would be VDS as well. But a lot of these are going to be delivered over the internet. And that's possible because none of these vessels are going to be far from shore. They'll all be within range of terrestrial communications. So the internet will be used for some of this data.
Okay. Can you just do one flick to the next slide just for me? I think the next slide is the one where you have the MASS environment. Yeah, the MASS package there. Okay, thank you. And just sort of seeing what's still there. So this word, the marketplace concept there.
Yeah, now the marketplace, that's something that has come up recently for us, but it's a way for the user to well, I'm thinking here more the mariner to be able to subscribe to services in a very simple way, and it also has there's a commercial aspect to it because our well, I wouldn't say not my company's code, but Kongsberg Maritime's customers, they don't want to receive a lot of different invoices for also they want everything to be consolidated in one thing. So it's going to be a way that both the safety related services for eNavigation and the more commercial services that Kongsberg Maritime and Kongsberg Digital provide, it's consolidated there.
Okay.
So that's what the marketplace is about. Yeah.
Okay, those are just a couple of little things that popped into my eyes as they were flipping by there. And I guess just thinking about your discussion on the virtual ATONs and the smart buoys and going back to our presentation of last week when we looked at in detail at the secure sync and resilient PNT, I guess I can see some sort of things coming together as this is all being developed, because I think position navigation and timing are really critical in all of the work that we're doing in this area. Yeah, very good. Okay, thank you very much. Are there any questions, please? Well, that's wonderful, and we're right on time. Thank you very much for that. We'll move now to, and I think I did see them arrive, Frank Montenij and Bastian Thewen on DAB+. Can I thought I saw you guys. Yes, there you are. So please, over to you.
Hi, thank you.
I don't know if Jeffrey arrived as well, but he did give me your names, and welcome to eNavigation Working Group 2, and we're looking forward very much to this presentation on some of the work that you've been doing on the digital VHF. And I'll let you know as soon as I can see your screen. I can see you. That's good. That's a good start. That's a good start. And yeah, very good.
Coming up.
It's coming. There it is. I see your presentation now. Thank you.
Yeah.
It's there. Thank you. Thank you, Frank and Bastian. Over to you.
Yeah. Well, good morning, everyone, or good afternoon, or good evening, wherever you are. My name is Bastian, and this is Frank. And we are interns at the Rotterdam University of Applied Sciences. And we're working for Rijkswaterstaat, which is a Dutch ministry that manages all the roadworks and waterways in the Netherlands. And we have been tasked to improve communication on the North Sea and on the waters in general. And we aim to do that by using DAB. So.
Yes, As Bastian said, we're interns and we're working at Rijkswaterstaat. In there, there is a field lab called Connectivity Field Lab North Sea, which is where we're stationed. And the mission of CFNS is to have a fully digital connected territorial waters and EEZ by 2030. Yeah, next slide. Yes. The communication at the North Sea now mostly goes through analog communication, the marathon, and other communication. There is AIS and different technologies, but we try to explore it with DAB and with different technologies. So we will, our mission is to increase the situational awareness on the North Sea by improving the connectivity and to active monitoring ships and of ships and replacing the satellite phone by VHF radios. Yes, next slide.
So DAB, for those that don't know, DAB is a digital radio standard. I think it was invented a pretty long time ago in the 1980s. And so the technology already exists, the infrastructure exists, and there are several advantages to using this technology at sea, we believe, such as that there is built-in error correction. It has a very long range. On land, this could be over 70 kilometers. And we believe at sea it might be even more, but we have yet to test this. Messages can also be encrypted. Really, any arbitrary data could be sent over DAB. And the receivers are relatively inexpensive. The only disadvantage is that DAB is only a simplex communication, so it's just a one-way communication. So Frank is going to tell you something about this later. He is researching some other ways to send data backwards or back. So we've been exploring this since September 2020. A couple interns before me, they designed the initial draft and they did research on how DAB can be used. Then in February, other interns, they started experimenting with sending data over DAB. And I just started last month, and I'm going to experiment with sending emergency warning messages over DAB. So, as I said before, various kinds of data can be sent over this standard, such as a weather forecast, chart updates for a chart plotter, or as I'm researching right now, emergency warnings. Frank is also working to integrate chart updates into the internal systems of ships to directly integrate it with the chart plotter, which is very interesting. Over to you.
Yes, as Bastian already said, I'm working on the acknowledgement part because DAB is a simplex communication. We are exploring ways to acknowledge the messages so we can confirm if a message is being received in the proper way by the ships, because the DAB will be sent from shore to ship. Next slide. In February to June, a intern has worked on a proof of concept for this module. he worked on the proof of concept is called half duplex, which, as its name suggests, tries to make the system half duplex. He used different kind of technologies to send an acknowledgement, and he but in this situation the modem is sending acknowledgement via all the possible technologies that are supported, and right now that are 3 technologies, so 3 acknowledgements will be sent. I will be working on on the part I will be expanding this with with another technology, and I will try to make it smarter so that it will choose the best technology instead of all the technologies. And next slide. Yes, as I said, we use different technologies. Here you can see the hardware of the technologies we send. We use AIS, as you can see on the left 2 images, top left images. One back, yes. On the right, you can see we use LTE, so we can also reach persons by phone. And we also use LoRa to send it back, because the ships are, in our use case, a long way from shore. So we will try to use the long distance technologies. Next slide. Yes, here you can see an overview of how we receive this, because it is good that we can send it, but we also need to be able to receive it at shore. On the top left, you can see the AIS messages, and then in the value column at the bottom row, you can see the message, the data that's being sent. Right now, it's just a simple DAB message identifier and a message type. So we can identify which acknowledgement this message belongs to. And you can see it's also for the other technologies. Next slide. Now, here you can see an overview of how our system is at the moment. The blue parts are the ones that already have been developed, and that's the current situation. The green blocks will be where I will be working on this intern, and the yellow one will be where our partner, the Coast Guard, will be working on. So the interface, I will provide the information that we receive, and then the Coast Guard will implement it and will send it to the right systems on board. As you can see, I will be working on the smart module for choosing the right technology, and I will be expanding the modem with Wi-Fi 6. Yes, next question, next slide.
Yeah, that's all we have for you. If you want to have a look at what else our field lab has to offer, you can have a look on our website, cfns.nl. Are there any questions from the audience?
Thank you very much for a very interesting presentation, and I am looking to see if there's any questions. It's very. Can you just go back one slide?
Yeah, of course.
Please? Yeah, that one's really interesting to see, because, and as you said, DAB is a relative. It's a fairly mature. I guess we could call it mature standard, isn't it? Came out in the 1980s.
Yeah, you can certainly say that. It's still being developed, actually.
Yeah, it's mature. It's been around, but it is continuing to be developed. But it is interesting to see on that slide all that is already developed and is underway and is being used. So that's just Interesting. So this smart acknowledgement module is in development now, and that is going to link with that server with that Wi-Fi 6. Oh, very interesting. Thank you. Just leave that slide up just for a moment in case there's any questions on that or any of the technology. I know what we had a presentation as well on the trial that happened. So are there any questions out there on the developments of the digital VHF? So there is
someone
a question up here. Yeah. What is the data rate when sending the information?
It depends on, because DAB is the radio technology. So on one ensemble, as they call it, one broadcasting tower can send multiple radio stations, and on each one of these radio stations can also be used as a data channel. And I think the theoretical maximum bit rate is about 200 kilobits per second. But this naturally also limits the amount of radio stations that you can fit on one tower. I'm not sure the exact number, but the limit for one station is about 200, as far as I remember.
And that's 200 kilobits per second for the tower, not, and then you'd have to divide that out amongst the different stations that are out there, how much you could actually get out, depending on how many are being used at any one time.
Yeah, exactly. So,
okay.
Does that answer your question, Ernie?
Does that answer your question, Ernie? Anything further?
Yeah, I was thinking more about if we have to send, for instance, an ice chart, or we have to send a chart update, which would be broadcast to everybody inside the area. This would be, let's say 10 kilobits of data. How long would it take from when that image is sent to is to rebroadcast to ships? How long would it go out? How long would it take to go out? So I understand that DAB has 200 kilobits per second capability, but the actual availability to this service, is that a part of a channel? Is it one radio station, or is it or is that not yet defined?
This is one station. This is just one station. I'm not sure if you could use up the entire bandwidth of the tower to send data at a very large bit rate. I'm not sure if that's possible. I haven't researched that yet. I've only tested with up to 128 kilobits myself, and that works. The 200 is just the theoretical maximum from what I've read in the standard.
Great, thank you.
Okay, that's excellent. Thank you very much for that. Any further questions? Except for the one, I guess, that we all, not necessarily question, just a comment that we all know, and that is that at the ITU World Radio Conference, we didn't actually get spectrum for the use of the VHF digital voice on that. I don't know if anyone here would like to have any further comment on that, or what the next steps are to get. We have a system that actually can work. How do we manage to ensure that we've got the spectrum available for it to work on? And no one's biting on that. There is work on the go right now. I know that when we first mentioned this at the working group too, Hideki did note the work that the discussions that had been had at ITU, and also the work that is going on to promote this in the future. So if there are no further questions on that, just from your future work that you have going on, when do you expect to be able to present on the next stage of your work?
Sorry, I was muted there. We're hoping next year that in the meantime we'll be able to test at sea, because we're really looking forward that we haven't been able to do that due to the COVID restrictions. So yeah, we hope that. I'm very excited.
We have this meeting of this group every 6 months, so perhaps Maybe we'll put a little bit of a marker down. If, say, in 6 months, if you have a further update, then it might be good to see how the work is going and where we're at with the ability to transfer that data over, and that the smart acknowledgement module, I'm really interested to see how that goes. And then also, obviously, that interface, how that the message queue goes through the interface and then goes on to the ship.
Perhaps we will, because we'll be finished in February. So the next group will take over then. So there'll be some other folks presenting here then.
Okay.
They may be able to present our work then.
That's great. Thank you very much for that. Jeffrey, as I think you've been involved in this work, did you have anything further you want to say before I close out and move on to the next presenter?
Hi, Jillian. Hi, everybody. No, not at the moment. I'm glad they gave the presentations, and I also learned something from it, so that's good. So please. Yeah, I'm obviously my vacation week, so I'm sitting in the camping place now at the moment, watching it. So that's why I'm not putting on my screen that kind of stuff. So, but it's good they gave the presentation. I hope it was useful for everybody.
Thank you very much. It was very good, Jeffrey. Thank you very much for organizing it. And also, I think last year about this time you were on holidays and we had you presenting to us as well. So I think it was on the same topic. Thank you very much for your presentation. I'm very, very interested to see how the work goes, and we will look forward to seeing some further updates on the developments. So well done.
Definitely. Thank you again for having us.
Okay, and I have to thank everyone for being so incredibly on time with their presentations and also with their questions. So now that brings me to the last presentation for today's session. I am passing over to Michael Bergmann for his presentation on the Global Digital Route Testbed. Over to you, Michael.
Yes, thank you very much for giving me the opportunity to present here the Global Maritime Digital Route Testbed. We are in an early stage of that project, actually in a pre-stage of the project, and I'm glad I can actually present that. IALA is one of the sponsoring organizations, and I want to quickly give you a briefing on what GMDRT is all about, is envisioned, and what are the timelines we are talking about. So let's see, I can change it. Yeah. So what is the concept of the GMDRT? The idea actually comes from Korean Ministry of Ocean and Fishery. Sam Bae-hong has presented that, I think, first time about 2 years ago. And then again, with more intensity, so to speak, last year and then this year at the digital shipping. The idea behind it is that ultimately SOLAS vessels are ocean-going vessels which are passing through regions, passing continents, and passing different oceans. So far, eNavigation testbeds were usually national or regionally focused. We have the STM validation project in Europe. We have projects in Singapore. We have projects in Korea like Smart Navigation. We have projects in Canada, in the US, and elsewhere in the country, Australia, and so on and so forth. What the idea behind GMDRT is to validate the capability of eNavigation services across ocean-going voyages between the Republic of Korea and Europe, and showing how different aspects of eNavigation could be utilized as ships are passing through. One example would be that a ship which is leaving Busan with the intent to call a port like Valencia, Hamburg, or Rotterdam, are sending their voyage information upfront in the respective formats, getting that received, and then adapt the voyage depending on availability of the calling ports. Also on the idea is that on the voyage information about the passage to the Malacca Straits, information about the piracy, escort information when passing the Gulf of Aden, information about the possibility to pass the Suez Canal, other areas may be shared, and the ship can then adjust the voyage accordingly, and also inform the port of call about potential delays or about potential early arrivals. So that's the idea behind it. And the MCP, what we likely already heard from Thomas about, is one of the vehicles which is intended to be used to share information, similar to what Todd already was referring to. We take a look to the GMDRT phase 1 project, the first part which we are currently working on. We have right now 2 execution bodies. The initiator and the host is the Ministry of Ocean and Fishery of the Republic of Korea. And there is one study on the global maritime digital route testbed establishment and cooperation with the area of Korea being established or analyzed, and the analyzation body is CRISO, the Korean Research Institute of Ships and Ocean Engineering. And for the European side, my company, Bergmann Marine, is tasked to conduct the study for the European knot of that global project. What we are starting to identify in the first phase is the feasibility in the 2 different knots, in the Korean knot and the European knot, what is available, what could be used. And stakeholder involvement is an important part. We have project support organizations like IALA, IMO, IHO, and others. We're also looking and communicating with ports and port actors. These are the ports and port organizations, terminals, tugboat operators, pilots, and so on and so forth. We're also talking with shipping lines, where their ships are actually calling the different ports in question. Other stakeholders are data providers like hydrographic offices, the regional ENC coordination centers, the value-added resellers, and also other service providers, data service providers, which may provide information like oceanographic information, cartographic information, or other information which are needed. And especially in the presentation of Todd, we saw quite a few of those potential data feeds which are in support of eNavigation and could be used. We also talked to coastal administrations and governmental organizations like, for example, VTS, Coast Guard, and others which are involved in the ship traffics and in ships entering the national boundaries, the national waters. Another very important aspect of stakeholders are the service providers. So anybody who provides communication, satellite communication, others. The MCP service providers, which Thomas was talking about, are those which are being talked to and are stakeholders. And here, especially this interrelation between different instances is something which we want to validate through the project. So when a ship, for example, is in Busan and leaving Busan, they may use the MCP instance from Korea. And then when they are traveling in Europe, other MCPs, whether these are from marine fields or from Navilink or so, may kick in and may be utilized as well. And those interactions between the different installations and service providers will be one aspect. And then we also have a few research institutes which are interested to join and do the necessary academic research, academic analysis, and so on and so forth to support the project and help us to also document all the necessary aspects. What is a bit different with these projects, the intention of this project with other eNavigation projects we have seen, especially at the beginning of eNavigation, is the intention is that it reaches further in the implementation. So it's not necessarily, it is a test bed, but it is intended to use existing implementations. So there is not it's not a research project as such. It is a project of developing concepts of implementing eNavigation on grant voyages. From the timeline we are talking about right now, and that is under discussion, will be further under discussion as we are reaching 2022, is that right now in 2021, we are doing, as I explained before, the first phase, which is building feasibility studies. Then the feasibility studies of the Korean knot and the European knot will be brought together, will be harmonized, and will create a common vision of how GMDRT should be executed. In the next phase, which is currently envisioned for Q2 of 2022, next year, is once we have consolidated our components and what we're going to do, discuss with the partners, the potential partners which are already involved, and see whether they are likely to join the project, sign memorandums of understanding, create the project consortium, and then identify fundings. We already have done so, but we then need to get to the funding bodies and explain what we do and see how we can apply for that funding. We also plan in Q2 and Q3 of next year to prepare the full project details, apply for the funding, and then launch the project, the actual project, in 2023. Depending on the work being done in 2022, that may be as early as Q1 2023. It may be a little bit later, also depending on the availability of funding and the availability of the project partners. And then we will have the execution phase, initial phase, execution phase, and then project closeout. So we are looking at a project which starts full swing 2023 and potentially goes over a period of 3 years, potentially a bit longer, potentially a bit shorter. That all will be defined next year when we are preparing the full project details. So I think that is, in a nutshell, what we are trying to do with the GMDRT projects. If you have questions or if you're interested to hear more, then you can get in touch with me.
Thank you very much. Very interesting. And again, thank you very much for staying on time. I'd like to thank all of the speakers for being so frugal with their time, because we actually have a few minutes left now. Are there any questions for Michael on that project? And I noticed that you made the link and the discussion so that this project is linked in with the use of the MCP and Navilink as well, so that you'll be using that for that, I guess, that concept of trust to identify and to discover those services that then will be able to be delivered.
Exactly.
That's very good, and it's good to have that link between these various ones. Are there any questions for Michael on this? Thomas, yes.
Yep, thank you. Was there any component of mass in this? Is that envisioned in this testbed?
Well, I think we need to talk about it, how far we want to go on mass. In general, I think what we are testing out here will be a prerequisite for mass. Will it work on a long route crossing different regions? So whatever happens to be tested on ships with crews on board can also validate the technology for mass and how that is included. It is currently not envisioned that we actually have mass ships available which are using that, because as we also have seen, for example, in Todd's examples, mass utilization is at the moment not yet in the full swing on ocean-going vessels. If that comes up, we can adjust the project plans to include things.
Thank you for that. I'm just checking to see if there's any further on the presentations as a whole. We may not have all the speakers available. Any presentations or any questions that you're seeing as you're starting to see these different, unique or disparate presentations provided? Are you starting to see any links or any areas of overlap that we could be looking at from the point of view of, I mean, we do in Working Group 2 focus mostly on digital communications and developments in the digital communications, but we're looking at the use of technology and digital transformation of the industry and how that is affecting. Some of the technologies might be developing, which is actually in our title, but we also know that there's a lot of developments that are coming from existing technologies that we're able then to implement and move. Okay. Yes, Michael.
Yeah, I just want to note when you talked about it, it just occurred to me that one of the stakeholders we have in now also the series of simulators, VTS simulators. So which means we also are planning on potentially integrating VTS simulators in the VTS communication exchange to allow the testing of the interchange between ships and VTS scenarios, even if in some areas it may be more difficult to interrupt the actual VTS work with those testings. So just that you know, these testing, we, for example, have one of the VTS simulation centers, which is connected to all the national VTS centers, which means they get all the necessary information, like running live VTS, but are working on a not helping actual ships doing that, so they are not interrupted if they are trying to interact with a test vessel.
Okay, thank you. And then I've had some discussions as well then on a bit of a tangential line, but we were also talking about maritime services a bit earlier, and that is the presentation. So in Todd's presentation, he noted the 3 existing maritime services linked to VTS, and then the thought that, you know, those are going to become perhaps one service into the future. Jeffrey, if you're still here, you might have some comments on this. But what about this idea of the maritime service descriptions and how they actually transfer the data? You mentioned about the VTS simulator, the actual data exchange and decoupling the maritime service focus perhaps away from what was in the old resolution, because I know that the new resolutions get in the way of INTNAS and TOS, so those aren't going to be there. But there is still the need to transfer information, such as what Todd was presenting, to do different requirements, to address different options, and one of them is this route exchange. So I'm just sort of trying to speak out, think out loud here about the way that these might be linking and how the maritime services fit in with the work that is happening and where the role of IALA might be moving forward. Yes, Michael.
Yes, thank you very much, Wolf. From what what I have researched so far, the different maritime services are all needing information exchange. And as such, the work which we are doing here is affecting not only MS1, MS2, MS3, and MS5 potentially, but also others. So especially when I take a look to MS4 port support services for those ports which are in areas where potentially not a full-blown VTS is available, EALA has guidelines for these as well and is involved with that. Or when I go further with meteorological informations and search and rescue, these are also things where I think that EALA is interested. So in essence, I think what we are doing here, especially when I heard the good presentation on DAB, that is something which I think will help us on various maritime services and is not really tied up with a specific maritime service.
Thank you for that. Oh, thank you everybody for your very interesting presentations. I'm just going to open up again for one last moment for some questions. And if I don't have any questions, then we'll let you go early. Oh, Thomas.
Yes, it's just on this matter of maritime services and maritime technical services. I think that because the maritime services do not exchange any data. They're on a very high level describing services on a very generic, non-technical way. But I think we're getting into a place where we are actually getting the maritime services and the technical services linked together. I know that there's a group in EALA working on a proposed new maritime service for ATONs, and they are referring now to a technical service for the provision of ATON information using the S125 and S201 product specifications. So there we have the link between the maritime services and the technical services. So I think it is very, very important that we're getting to that point where we are sort of populating the maritime services with the associated technical services that actually does the information exchange.
Thank you. And then that brings me to the point that when we get to that, which is probably where this working group comes in a bit more, is how much bandwidth do you need? How much data is being transferred? What is the data rate that we're going to be requiring? And so therefore, what would be the most applicable technology to be able to do that?
Which would probably differ from service to service. Yeah.
Michael, did you put your hand up again, or is that still up from before?
No, I don't have my hand up, but
No.
I just was about to do so. So maybe you have some forward-looking views here. I think it was a very important point, but was just brought up. And what we also will test in GMDRT is when do we actually need to communicate what to reduce bandwidths. So, for example, when we have MS11 nautical chart service or the MS15 real-time hydrographic environmental information, I do not need real-time information from the German Bay when I am leaving Busan. So always sharing those information when it is not yet worth doing that, it's irrelevant. So the testing will also be, so when do I actually need certain information? When do I need those information no longer? And when do I disconnect with certain data streams? And when do I reconnect to certain data streams to reduce the amount of necessary bandwidth for my ship? And I think that is of essence for our group here as well, what will be the results of those analysis. Very interesting.
And it sort of brings to mind as well that smart module that they're developing in that DAB work, which is sort of identifying what needs to go when and where and how much bandwidth do you need at that time, and then what's the best. I think Todd was talking about that as well. What's the best service to use? What's the best connection? So I should have to be careful when I use that word service. What's the best connection to use to get that through? thank you for all of that, and thank you for your participation, everyone. One last call for questions before I close out this session. Ernie, as Vice Chair of the working group, anything further from you before I close out the session?
No, Gillian, thank you very much. It's all really good and very interesting. And I'm sure there'll be lots of discussion that follows out of this.
Yes, thank you very much. So just to remind you again, we've had a very good presentation on the Maritime Connectivity Platform in MASS from Thomas, nonlinear decision support and automation in VTS from Todd, the DAB Plus from Frank and Bastien, and the Global Digital Route Testbed from Michael. Now, for Working Group 2, I'm just closing out the meeting for now, but just to remind you, Working Group 2 Plenary, which is our official closing session, where we will review and revise our Working Group 2 report and discuss our intersessional work, which we have been proposing. That is tomorrow at 09:30 to 1100 UTC. We will have two further sessions after that, but our report from the working group must be in by the 26th of October to meet up in time for our closing plenary. So thank you very much, and I look forward to seeing many of the Working Group 2 members again tomorrow at 09:30 UTC. Good night, everybody.
Thank you.
Try and get
Good
my
night.
work. I don't know if it will work. I always wonder.
Thank you, Gillian.
Gillian, just a moment.
Oh yes, Kezu. Yes,
Yeah.
please go ahead.
Yeah, I just noticed that tomorrow's meeting, I think it's not in the dashboard.
Oh, well, thank you for that. I will follow up and find out where that it should have been there because all of the meetings were entered, but I will double check and see what it is.
Yeah.
Thank you.
Okay.
Very much.
Thank you. Yes.
Okay.
Okay.
Thank you.
Bye. Good
Bye
night.
bye.
Bye-bye. Bye-bye.
Hi.
Bye. Hmm.